Hey, so here we are in the Codefights arcade. We're going to do a couple of tasks. Today we're going to look at 6 and 7, make rate consecutive and almost increase in sequence. So we'll get started with this guy here. I've got a few ideas for some topics we want to look at here, but let's get started with what the problem's all about.
Radio got statues of different sizes as a present from Codemaster for his birthday, each statue having a non-negative integer size. Since he likes to make things perfect, he wants to arrange them from smallest to largest so that each statue will be bigger than the previous one exactly by one. He may need some additional statues to be able to accomplish that. Help him figure out the minimum number of additional statues needed.
Okay, so let's start by trying to visualize the problem. If we look at the example over here, we've got statues, so 6, 2, 3, 8. Let's start with that as an array over here. So 6, 2, 3, and 8. Alright, so basically we want to organize these from shortest to tallest. So our shortest one is going to be 2, and our tallest one is going to be 8. Okay, so ultimately what we're looking for is something kind of like this. So we have statue with height 2, 3, 4, 5, 6, 7, 8. Alright, so then in terms of our array here, we do have 2, we do have 3, we do not have 4, we don't have 5, but we do have 6, no 7, and yes 8. Okay, so basically the ones we need are the 4, the 5, and the 7. That's just going to give us this sort of ascending sequence over here. But if we look at the problem, if we look at the actual description of the problem here, it's just saying help him figure out how many he needs. So we don't actually need to know the specific ones. We don't have to know that it's 4, 5, and 7. All we need to know is that there are 3 of them that are missing. The 3 of them we need to add. So basically for that example, for 6, 2, 3, 8, we would add 3 statues, so our answer is 3. We would return 3 for that example. Okay, so if we think about how we could get that 3, how we actually got the answer from that, we could just sort of take a look at the process we just ran through. So basically, we identified the minimum number, we identified the maximum number, and then I just sort of iterated through those, just checking at each one of them to see if that number is in the array or not. So we could basically make an algorithm do exactly that. So find the minimum, find the maximum, and then iterate through and see which ones are in the array. So let's start with that. So for now, let's do it this way. We'll say we're going to have variables min and max, and I'm not going to assign any values to them yet. We'll take a look at how to do those in just a sec, but assuming we can get our min and max, let's iterate through those. So basically, we're going to have, I guess we'll have another variable, something like, I don't know, counter or whatever you want to call it, basically just something to represent how many of these things we're going to need. And so ultimately, that's the thing we're going to be returning at the end. So we're going to be giving back counter, which is just how many statues are we missing. So in terms of how we're going to figure out if they're missing, we basically want to run through something like this. So we'll start with the variable I. It's going to start as minimum. It's going to go as far as maximum, and we're just going to add 1 for each iteration. And then basically, inside the loop, what we want to do is check if statues at I, sorry, actually, check if I is in statues. Basically, we just want to check if the number I is going to be inside that array. And in fact, maybe I is not the best variable to use here because you might think it's an iterator or an index or something like that. But really, we use n because we're talking about a number here. So we want to check if n is in statues, if the array statues contains the number n. Okay, so how are we going to check if n is in statues? So that's where this first thing comes in here. So indexOf. Basically, the way we used to do this is we'd say something like if statues.indexOf n is greater than -1, then we would do something from there. But just to give a sense of what this indexOf is doing, we can just throw in a little return statement here. We'll say statues.indexOf, and what's the number? We'll use 3 for now. Okay, so I'm going to run the test. Control R, or Command R is a keyboard shortcut for that. So for this first one, it's outputting 2 right now. Why is it outputting 2? Well, I'm asking it for the index of the number 3. And so basically it's taking the array statues. In this case, statues is 6238. So it's saying 3 is in there. Its index here is 2. 0, 1, 2, 3. So this one's 2. Whereas in another example, like if we look at this one, yeah, there's a 3, but now its index would be 1, 0, 1. So it's returning 1 instead of 2 as in the previous one. If we look at the third one here, we don't have a 3 in this array, so we're returning -1. So basically that's the default behavior for indexOf. If it doesn't find the thing in the array, it's just going to give you a -1. So basically when we do this thing down here, and yeah, I guess I'll get rid of that for now. When we do this thing down here, so if statues.indexOf n is greater than -1, we're basically saying if n is inside statues, if statues has that value n. Okay, and then we want to do something. Let's be more specific about what we want to do. If it does have it, then well, I guess we actually don't want to do anything in that case. We want to iterate counter, but that's only if it doesn't have it. So instead, let's make it like this. We'll say if it is -1, in that case, we want to iterate counter, because that means we're missing one of the numbers that we need. Okay, so we'll do something like that, and I mean that's pretty much going to be it. We're just going to go from the minimum to the maximum, and for each number, we're just going to check does statues have that number in it. And that'll work, but the problem right now is we don't know what the min and the max are. So let's look at a few ways of doing that. So first of all, we could say let me just separate these, our min and our max. So for min, there's a few ways doing this. I mean, I just want to look at the first example for now. So I'm going to say the min is 2 and the max is 8, since we already knew that from the first example. We'll just run this to see if it works. Okay, so what we see here is test 1 right off the bat. It's good. It's giving us the right answer. It's saying 3. And, you know, maybe we might think that that's just a coincidence or something like that. So let's add another line here just to make it absolutely clear that we didn't just get lucky with that 3 here. So console.log, that's basically just going to output to this over here, console output, console.log, and let's just say something like n, and then I'm going to add a string too. I'm going to concatenate a string. This number n is not in the array. Okay. So basically, if we run this now, nothing's going to change in terms of the way the program's working, but since we have this console log here, it's going to say, oh, okay, so, oh, whoops, wrong example. Here we go. Yeah, for this first one, it's saying 4 is not in the array, 5 is not in the array, 7 is not in the array. So those, as you might recall, those are the three, 4, 5, and 7. Those were the ones that we needed to add. So this is working the way we want it to be working. So that's good. If we look at some of the others, though, there's a problem here. Now it's saying 2 is not in the array, 4 is not in the array, 5, 6, 7, 8. Lots of numbers that aren't in the array. But that shouldn't be an issue because it's supposed to only go from 0 to 3. So really we should only have to fill in 1 and 2, which is why the expected output is 2. There are 2 of them that are missing. Okay, so the problem here is obviously that we didn't put in the right min and max. So we just use the default values from the first one. We need to actually talk about how we can find the min and max. But before we do, I just want to sort of close the loop on this first one over here. So instead of this, there's actually a newer syntax we can use. So instead of using indexOf, we can use, I would argue, slightly more semantic syntax here. So we'd say statues dot includes n. But since we're actually trying to say that it doesn't include n, looking to see if n's not in it, we're going to put an exclamation point at the beginning just to mean not. So this is just going to return the opposite Boolean of whatever it normally would. So basically, if this thing is false, then not this thing is true, and vice versa. So if we run the test, this should run exactly the same. We should pass the first test, and I think fail all the other ones right now, unless we just happen to get lucky with some of the others. Yeah, okay, so it's passing the first one, failing all the others. Great. But that's what we're expecting right now. We only want it to pass the first one because that's what the min and max are set up for. But we'll change that. So now that we've gone through the index of and includes, I mean, this is the notation I normally use. I'm not sure if there might be issues with it. I'm not sure which one's better, but this is the one I normally use just because it tends to be clear to the reader. For loops are another thing I want to talk about. We've got one right here. It's, in case you're not familiar, this is our initial condition. So setting up a variable, you can put whatever you want here. You don't actually have to put anything here if you don't want to. You just have to include the semicolon. The thing in the middle is basically the condition that's going to allow the loop to keep going. So as long as n is less than or equal to the maximum, it'll keep the loop going. And this is what it's going to do every time it does keep it going. So basically it gets to the end, it'll iterate n gets 1 bigger. If it's still less than or equal to the max, it'll continue and it'll execute all this code in here. Let me just trim this a little bit. Okay, so now we want to talk about the min and the max. So there are a few ways that we can do this, a few ways we can find the min and the max. The first thing I want to talk about is, I guess we'll use the reduce method. So reduce is a really interesting type of function. It's a JavaScript built-in. It works on arrays. So statues is an array. Let's try reduce just to sort of get an idea for how it's working. So I'm just going to put a little return. You'll notice if I put a return at the top of the code here, it's not going to execute anything that comes after it. As soon as you return something, as soon as a function returns something, it's done. It's not going to bother with anything that comes after that. It's done its job. It returns. It doesn't execute anything more. So I basically, by putting this return statement at the top, it's just going to ignore everything that's going to come after this. So that's kind of nice. I don't have to delete it or comment it out. It's not going to affect anything. So what we're going to return is statues dot reduce. And reduce takes as an argument a function. It's going to be a function that has 2 variables. And this is maybe starting to look a little bit intense, but we'll go through this one step at a time. So basically, A and B, you might think that these sort of represent 2 elements in the array, like the first and second element. And in the first step, they do, but it's going to get a little bit complicated in terms of what they actually represent. So this is a function now. As our argument for reduce. So since it's a function, it needs to return something. I just want to go with a very basic example right now. So I'm going to go with A plus B. So a reduce, we're doing a reduce on statues. It's taking this argument, which is a function. This function just adds 2 numbers. That's it. You know, it's a very, very simple function. It just adds 2 numbers together. It takes 2 numbers as arguments, returns their sum. Okay, so basically, if we take a look at what this is going to do, I'm getting 19 here. So if you look carefully at the array, you notice that 19 is what we would get if we were to add all these numbers together. 6 plus 3 is 9, 2 plus 8 is 10, 10 plus 9, we get 19. Okay, so basically this is the sum of all the numbers. This is kind of interesting because my function in here says a plus b, but it went and did more than just adding the first two numbers. It added basically all the numbers in the array. So let's take a look at how this works in terms of our a and b here. We've got our 6, 2, 3, 8. That's well, it's still the array that we're using here. So just get some of this other stuff out of the way here, and we'll just return to this array, and we'll talk about what that reduce thing is doing. Okay, so for reduce, basically we have a, and we're going to have b. So in the first step, a is going to be 6, and b is going to be 2. And if we remember a function, it's basically just saying take a and b and return a plus b. So the way reduce works is it's going to go through the array one step at a time. And it's going to use different values for a and b as it goes through. So originally a and b are just the first two numbers. As soon as it runs the function, so when it does this return a plus b, what it's actually returning it to is the value of a. So after this step, a, instead of being 6, it's going to be 8. So a is 8 now, because it added 6 and 2. And then b just gets the value of the next element in the array that we haven't seen yet. So now b is going to be 3. So at this stage, a is 8, b is 3. It's again going to run the function which says a plus b, so it's going to add 8 and 3. And again, it's going to store that value in a. So now a is going to be 11, and b is just going to be the next element of the array. So b is 8, and then finally it adds those two, and that's going to give us our 19. Thing is, there isn't anything left here. There isn't another value that b can be equal to, so it's actually just going to return this as our final number. So reduce, if we want to put it generally, it's a built-in function that we can use to take all the elements in an array and basically flatten it down to just a single value. Whether that be a string or a number or some other kind of data type. The main thing is that reduce takes an array and reduces it to one number. That's the principle. So we can make this do other stuff. It doesn't have to be a plus b. We can make it do something kind of weird like a minus b. So we're probably not going to get a very meaningful answer out of that. We're getting -7. Okay, so why are we getting -7? Well, let's look at how this would be different if we weren't adding these numbers. So all the b's are going to be the same, but now the a's are going to be different because they're going to be the result of subtracting the numbers instead of adding the numbers. So 6 minus 2, that's going to give us 4. 4 minus 3, that's going to give us 1. 1 minus 8, that's going to give us -7. And if we compare with the result we got over here, it was -7. Okay, so that's not super useful. I mean, the a plus b is something you might actually use. Probably you'll never do an a minus b in a reduce like this. But what we want to do here is we basically want to do we want to return the minimum value in this case. Let's say so. Let's say we wanted to find the minimum value in the array. So we would maybe do something like this. Well, there are a few ways we could do this, but let's start really simple. We'll say if a is less than b, then return a, because that would mean it's the smaller value. Otherwise, return b. So basically, if we look at the way this is going to run through, it's just going to return the smaller element each time. So it's going to compare a and b. It's going to say, is a less than b? Yeah, it is. Oh, okay, return a then. Or is a less than b? No, b is smaller. Okay, in that case, return b. So one way or another, we're going to get the smaller element. If a is smaller, we'll get that. If b is smaller, we'll get that. So again, we'll take a look at this. We'll see how this would look if we were using this new function, this new comparing function. and it's just taking the smaller of the two each time. So it'll compare 6 and 2, and it'll say, well, 2 is smaller than 6, so we're going to return 2. So A is going to have the value of 2 now. Returning, in that case, it was returning B, because A was 6, B was 2. Is 6 less than 2? No, it isn't, so it's returning the 2. Okay, so A has the value 2 now. Now it's going to compare 2 and 3. Is 2 less than 3? Yeah, it is. So we're going to return the 2. All right, and then final step, compares the 2 and the 8. Which one's smaller? It's still the 2. So it should be returning the 2 as a final value here. Let's see if it works that way. So we'll run the tests on this thing, and keep in mind, it's just executing this part. It's just ignoring everything below now. Okay, so I'm getting 2 in this case. Again, maybe I'm just getting lucky with that, so let's look at the other tests. In this case, 0, which is the minimum element. In this case, 4 is the smallest one, and this one, 3 is the smallest one. I think this is working the way it's supposed to be working. So all of this stuff here anyway, this is a way of getting our minimum element. This is going to give us the smallest element in the array. So we could use that and then use a very similar function for the maximum. But if we want, we could clean this up a little bit. So instead of saying if A is less than B, return A, else return B, we can use a ternary operator. So that's a nice little built-in feature of JavaScript. So it's going to do the same stuff as what we see above, except it's going to do it more efficiently. So we do it this way. We'll say return, and then we'll ask the statement up here. We'll ask our conditional statement, A is less than B. And we use a question mark. It's kind of like we're asking that as a question, you know? A is less than B. And then if it is less than B, then we'll return A. Otherwise, we'll return B. So this thing right here, this ternary operator, basically it's the question, and then a question mark, and then what to do if it's true, what to do if it's false. So basically, if this thing ends up being true, we'll return A. If this thing ends up being false, we're going to return B. So it should be doing the exact same thing as all this, but with fewer lines. So let's see if this still works. We're expecting to find the minimum again. So again, we still get the 2, we still get the 0, we still get the 4. Still seems to be working. So that's nice. It's a lot more efficient that way. And we could even make it a little more efficient if we wanted to use a fat arrow function, which is a nice ECMAScript 6 feature, some modern JavaScript, and you'll find these fat arrow functions really tend to speed things up, so it is something I recommend. So let's convert this to a fat arrow function. So basically, here, let me break this part of it out. We'll take a look at what we want to put as our argument. So this is ultimately what we're looking at. It's a function. It takes arguments A and B, and it returns either A or B, whichever one's smaller. I could have also given this function a name. Like, for example, we could say function, no, not sum. That's not what we're doing anymore. Minimize. So that's minimize, and then we could just pop that in here. Minimize, that's the name of our function. Let's see if that works. Yeah, still same thing. I mean, we're just making a reference to the function over here. I feel like it should be blue, but maybe it's because I'm declaring the function below. JavaScript uses something called, I believe it's called hoisting, where basically if you declare a function at a lower part of the page than where you're actually calling that function, it'll still understand it, because as far as I understand, the way hoisting works is when it's compiling this thing, it's going to take this function and put it up at the top. Any function declarations we have in here are just automatically going to be hoisted to the top. So we don't really have to worry about the order we lay this stuff down in. It might be smarter just to put it up top just for the sake of the reader, though, so they know it's coming up. Anyway, point is, this is what we want to summarize. I'm going to turn it back into anonymous function over here. Functions in JavaScript, they don't need to have names. I mean, we can just sort of declare them as we're using them. So since I was just using this as an argument, it was inside the reduce before, it doesn't really need a name. We're going to convert it to a fat arrow function, and then we're going to put it back in as the argument there. So basically, it's just going to be this, and it's going to return the same stuff. So this right here, that is exactly, or very close to being exactly the same as this. Now I could be wrong about this, but my understanding is that this actually doesn't get hoisted in the same way that this does. So I guess we could test that. So we could give this one a name, minimize, we'll call it again, and hey, why not a little bar on that? This is a way we can, like, this is a legitimate way of declaring a function now. It looks kind of weird. It doesn't look super JavaScripty, but it's just sort of a modern feature. So we'll see if this works. I'm expecting that this will not work. Yeah, it's basically saying, what are you talking about? This is undefined, this thing right here, minimize. We don't know what that is. Whereas if we were to put this below and run this, then I think it should work now, because, like, as you can see, the minimize is blue. It sort of knows. Yeah, the answer isn't right, but it worked. It gave us the minimum still. So that's the main difference. I mean, aside from just the efficiency of using one of these arrow functions, just keep in mind that it's not going to get hoisted necessarily in the same way that sort of a more classic function syntax would. But anyway, we don't actually even need to worry about the name of this thing or anything like that. We can just cut that right out and just put it in right here. It doesn't need to have a name. We can just say return that thing. So this dot reduce, and then this is our function. So that's, I mean, if we think back and compare that to what we had before, when there was a big function in here with an if and an else and all that, this is getting a lot more efficient. You know, it's looking a lot nicer, a lot terser than what we had before. So if you're someone who likes to do the code golfing challenges, the shortest character challenges on this site, then this is the sort of stuff that you can really benefit from. The ternary operators, the fat arrow functions, and even stuff like these built-in array functions like reduce. A lot of those can really let you do a lot of things very efficiently. Okay, so we found a way to find the minimum now. We could also find the maximum that way. But there's another thing I want to talk about, just still sort of hung up on this minimum thing. We have a built-in for finding maximums and minimums, and we could use that here. So instead of saying you know, if A is less than B, return A, otherwise return B, let's make it less complicated. Let's just say math.min A, B. And that should still work now. So math.min is a built-in. Again, math is a very popular library. There's lots of stuff you can do with it. We've even got some new features like log2 and sign and stuff like that, which are pretty useful. So, all right, we see that it's still giving us our minimum here. It's still giving us that 2 we were looking for, 0 on the next one, 4 on the next one. There we go. All right, so that's nice. That's, again, looking more efficient. And the other thing about math.min here, let's even get another return in here. Math.min 4 and -7. What's the minimum out of those ones? It's -7. Okay, makes sense. What if I added some other stuff though? What if I also had -11 and 15 and 32? Let's see how it deals with that. Can it have multiple arguments? Yeah, it can. So math.min can take a whole bunch of arguments. It's not just 2 things that it needs to compare at once. So we might look at this and say, well, look at the way we're doing this right now. We're sort of going through running through this whole array here and making a comparison at every turn. I mean, if we could just run a single math.min, that'd be nice. That would be an easier way to do it. So maybe let's try that. Math.min. Let's just do math.min of statues. And that should give us a... Now wait a minute. We're getting a null from that. So why would we get a null when we put statues in here? Well, it's because statues is an array. Math.min as a function, what it's looking for is a set of arguments. It's looking for multiple things. It's looking for 2 or more numbers that it can compare and tell us what the minimum one is. We're giving it an array. We're basically just giving it 1 argument right now. It doesn't have anything to compare to. So it doesn't really understand what we wanted to do with that, which is why we're just getting a null as our result here. Okay, but we don't want a null, so we might look at this and think, well, okay, there's got to be a way, right? I mean, there's got to be some way to communicate other than doing something like this. There's got to be some way to communicate to JavaScript that we want to use all of the elements in this array. We want to use the 6, the 2, the 3, and the 8 as the arguments here. We want something that basically looks like 6, 2, 3, 8, like that as the arguments to our function, as opposed to something like this, where the argument is just this single array. So how do we convert an array into a set of arguments for a function? Well, again, it turns out there's a really handy built-in in JavaScript. It's called the spread operator. And instead of just putting in statues like this, because remember, again, when we ran that thing, that gave us the null. So instead of that, we're going to spread it out. We're going to just take every element of the array and use each one of those as an argument. And the way we'll do that is just putting in a dot, dot, dot before it. So now when I run this, I should get exactly my 2 over here, the minimum value. And you might be thinking maybe it has something to do with this over here, but that's actually not necessary. We can get rid of that now. So if we run this, return math.min dot 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 statues. Okay, great. It's working 2, 0, 4. Great. Okay, so that's getting a lot nicer. That's really starting to look very efficient, very nice. So that's a way we can find the minimum. So let's just go ahead and grab that, and we'll just use it right here. We'll say that's going to be our minimum. You can probably guess how we're going to find the maximum. It's going to be something really similar, except instead of math.min, we're going to use math.max. And now this should probably work. I mean, the minimum and maximum, I'm not just typing them in manually based on the first test. It should actually find them. So minimum is going to find our minimum value like we saw before. It was 2. Maximum should be finding this 8 over here. And that's going to give us the boundaries of our for loop. That's going to tell the for loop to go from, in this case, 2 to 8, whereas in the next case it would go from 0 to 3. So let's see if it actually worked. Let's run the tests on that one. Okay, passing all the tests. So that's good. That's working. But maybe it can be better. So let's take a look here. We talked a bit about for loops. We talked about math.max, math.min. We've done reduce. We did the spread operator, which was the dot 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 over here. So what do we have left to talk about? Well, time complexity. So sometimes you probably see these, big O of n, big O of log n, stuff like that. That's basically just a measure of how long your algorithm is going to take, or more accurately, how the computation time is going to scale up as the size of your arguments scale up. Because if we look over here, I mean, we've got guaranteed constraints. These aren't too bad. It's basically saying your array is only going to have 10 things in it, and the values in it are only going to go from 0 to 20. So we actually really don't need to worry too much about computation time in this case, because it's just not going to be an issue. I mean, iterating through an array of 10 things is, you're never going to get the time limit exceeded in that case. And especially because, I mean, the size of the numbers is very small too. I mean, remember, our max and our min, if these were really outlandish, if this could go like 200,000 instead of just 20, well, then this array would actually be doing a little more serious work. It's not just going to cover 20 values. It might cover a whole bunch more. But anyway, the point is, right now, this is working. But just in case we had different constraints, in case we were dealing with a bigger kind of array, maybe we should consider that. Maybe we should just ask ourselves, what would be a better algorithm? So first of all, let's get rid of this console log. I mean, it's negligible. It's not going to make much of a difference in terms of our actual computation time here, but I don't think we really need it anymore. I mean, I think we have the evidence that our algorithm's working the way we want it to be working. So if we want to think about the time complexity first of all, let's think about this. So first of all, we've got this min function, and that's essentially running through the statues array. Then we've got the max function, and that's also running through the statues array again. And then after that, we're going through this loop that's going from the minimum to the maximum, so that could take some time. So this is sort of depending on the size of the array. It's also sort of depending on the size of the elements in the array. So we're looking at something here. This would probably be like a big O of n plus m. where n is the length of the array and m is sort of like the size of the numbers within the array, or technically in this case it would be the size of the spread between the numbers. So that's not bad, but it's not ideal. We can do better than that for this type of problem. So one thing that we could do just to get started here, I mean, if we look at our min and our max, it's actually running through the array twice to find these. So it spreads the statues out, it goes through them, finds the minimum, and then it does the exact same thing to find the maximum. We could do that more efficiently. It would be possible to do that more efficiently. So basically, one way we could do that is we could manually run through the array to find our min and our max. So let's originally leave these, we'll sort of leave them the way I had them before. They're going to be uninitialized. So we've declared them, but they don't have any values right now. We've got min and max. Or we could even just say, you know, that it's going to be statues at 0. There's actually, again, if you want code golfing tips, we can do it sort of like this. We can do it more efficiently. Min equals max, like that. But I'm just going to say min is statues at 0, and max is also statues, at 0. Okay. So I'm just starting them both with the initial value, the first value in the array. The reason I'm going to do that is because I'm just going to compare to every other value in the array. So I'm going to say for var I is assigned the value 0, I is less than statues.length, I plus plus. And then for each one of these, we'll just say, I guess maybe var num is going to be statues at I. And we'll say if num is less than min, then min is assigned the value of num. Notice I'm just using one line here for the if, so I don't actually need to put this in braces or anything like that. It's just a little more efficient. Again, if you're trying to shave off some bytes for those code golfing challenges, this would be a way of doing it. If num is greater than max, then now max is going to be num. So if we take a look at this, this should assign min and max the values that we're looking for, but at the same time, it's only running through the array once. So let's see if it works first of all. I really hope it does. There we go. Okay, so I'm passing all the visible tests at this point. And yeah, it's nicer because we don't have to run through the array twice. Again, that's not the sort of thing that's going to make like a really significant difference, but it's worth thinking about. So what else can we talk about while we're here, though? We've got this for loop, and it's kind of an old school way of doing for loops, saying specifically what we wanted to start with, under what condition we wanted to iterate, and going up by one. I mean, this is just, there's nothing about this that's really that different from the way we would normally go through an array. I mean, it's not like we're iterating I by some other number than 1. You know, we're not doing like I is the value of I plus 2 or something like that. You know, this is very, very natural. We're basically just saying go through every element of the array. We'll go through every index in the array. So there are other ways of doing this. We could say, you know, var I in statues. So this one is a little bit controversial, but it still works, or at least in this case it's going to work. This is used more for iterating through the keys in an object, a JavaScript object. So it's not really considered super proper, as far as I understand, to use this for an array. So we're not actually going to use this. Instead, we're actually going to do something that's even more efficient, because if you look at it, we're not actually using the index here. We don't care about the index. We don't really care like where in the array the number is. We care about what the number is. We want to know what number it is. So instead of saying var I in statues, we've got this really neat new syntax. We can say num of statues. And I don't need this part anymore because that's basically saying what I already wanted. Num actually is now just the value in the array, not the index of it, but the value itself. So now if we run this, it should work, first of all. I'll be embarrassed if it doesn't. We'll find out, though. And I guess while we're waiting, I'll just delete that part because we shouldn't need that anymore. And basically this is, there we go. So it's going through, and num is just, it's in this case the 6, it's the 2, it's the 3, it's the 8. It just goes through each of the values. So that's nice. Even though it might seem a little more verbose, it might seem like there's more stuff to type out here. In terms of computation time, it's going to run more smoothly. It's not going to take as much time to run the algorithm. So that's a nice advantage of this. We're not necessarily always looking for the most terse, shortest syntax. I mean, unless you're doing code golf or something like that, you want to consider it, but probably prioritize your computation time. We wouldn't want this timing out or anything like that. Okay, so we've got our algorithm. Seems like it's working. It's passing all our visible tests. But can we do better than that? Is there is there another way to think about this? Do we actually, for example, need this loop? Do we need to go through and check all of this stuff? Or maybe there's a more efficient way we could deal with that. So let's see. Is that diagram still there? Ah, no, it's not still there. Let's see. Maybe I'll try to find it. Yeah, there we go. Okay, so we had these three, 4, 5, and 7. Those were the ones that we needed to find. But again, we didn't need to know specifically that it's 4, 5, and 7. What mattered was just how many of them there were. So if you think about it, there's a way we could sort of predict that. So if we take a look at this, 4, 5, and 7 are the ones that we need to fill in here. But we could just ask ourselves, well, how many numbers are there in this range? So going from 2 to 8, how many numbers are we going to have? Looks like there are 7 of them here, so that's the same as 8 minus 2 plus 1. Okay, so that's how many we have total, or that's how many we want to have total. But what we're looking for is these ones, the 4, 5, and 7. We want to know which ones do we need. So basically we could just say, well, what's our total here? In this case, the total is 7. And then just how many do we have? We've got the 2, we've got the 3, we've got the 6, we've got the 8. Well, those all came from this array over here. So basically, if we just subtract this length, the length of this thing, which would be 4, we have 7 minus 4. Well, not a coincidence. That's going to give us 3. So let's think about where we're getting this. The 4 is the length of the array. So this is statues dot length. Okay, this one over here, statues dot length, and then this one was basically 8 minus 2. Well, 8 was the maximum, 2 was the minimum, so this is max minus min, and we add 1 to it because otherwise we just have the strict difference between these two numbers. We need to count the boundaries because we're including 2 and we're also including 8. So it's not just 6, it's going to be 7, so we need to add that 1. Okay, so basically the 7 here was max minus min plus 1, and the 4 here was statues.length. So we don't actually have to loop through this. We don't need to loop through and look at each value in here. All we really need to do is just a very simple subtraction. So we'll just do max minus min plus 1, and then subtract statues.length off of that. Let's try that. So I'm just going to put that in right here. Again, it's going to ignore everything below the return. So we had max minus min plus 1, and we're subtracting from that statues.length. Let's see if that's going to work. Is that going to reliably give us the right answers? Well, it's passing all the tests. And again, if you're not convinced that it's not running this stuff down here, we're going to delete that. And we're going to run the tests again. And that's very nice. Okay, that's very nice. The reason I say that is because we've just cut out a loop. That loop, I mean, consider if this was a bigger array. This isn't a very big array. It's only 10 elements. But what if it was huge? What if it was like 50,000 elements or something like that? That loop could be going on for a really long time. And depending what's in that loop, it could really take some time. It could time out, in fact. It could be the difference between passing the test and not passing it. So it really makes a significant impact if we can just take out an entire loop. I mean, look at what we just subtracted from this. We had all of this stuff over here. We have variables that we don't need to keep in memory anymore. We don't need this counter business or anything like that. We don't need to check if the statute includes the value. We don't need to run through the loop at all. All we need to do is this one calculation over here. So we would say that this part of it anyway, instead of being big O of n or something like that, it would be big O of 1. It's executing a constant time now, which is nice. I mean, that it doesn't really get better than that. Okay, so we talked about for loops. We've got this modern for loop structure over here using the of, which is pretty nice. And we've talked a little bit about time complexity here. So we know this is passing the visible tests. I guess at this point, let's see if it's nice and clean. If we like the way it looks, then we might as well just submit it and see if it works. And there we go. Okay, so that's nice because this is a really efficient algorithm. I'm pretty sure this is as efficient as this algorithm can be, which is a really good feeling. So again, we don't need to worry about that super a lot because of these guaranteed constraints. They're very forgiving in this case, but there are some challenges where that is not the case. And some of these you really have to worry about time complexity. You have to worry about how long it's going to take. And well, the next one we're going to look at is going to be like that. So we'll finish up with this. I think it's looking good. I mean, if we want to change anything here, let's see. Well, I guess, okay, one thing we can talk about is we've got these newer JavaScript features. We've got some more ES6 things we can use over here. So, I mean, var is not something that's really used as much anymore. With ES6, JavaScript lets us do, we've got let and this other one const now. So the difference mainly is in scoping. As I understand it, the way var used to work is it would be scoped to a function. It would be based on the function. But let is actually scoped to whatever kind of block we're dealing with. So like a conditional loop, something like that. So now if I put let here, for example, we wouldn't be able to find the value of num outside of this for loop. And actually, here, let me set this to let, and let's actually try to get that value of num. Return num. And it's probably going to ask me what I'm talking about. So reference error, num is not defined. And I'm thinking, well, what do you mean? It's right up here. So the idea is that now, since it's within this for loop, it's in the scope of this for loop. So really, num is something that only exists inside of this for loop. Whereas if this was a var, on the other hand, now it should just give me the last value that it finds. So the 8 was the last value that num had here, and since num is now accessible, it's just giving me that 8. It's just giving me the 3. It'll give me the 6 in this case. So we can access num outside of the scope of this for loop here. But if we were to change it to a let instead of a var, like we saw before, now we get this reference error. Const is similar in terms of the scoping, except it can't be overwritten. So it's an immutable variable now. So basically, num, well, actually, this isn't going to work at all. Even without this thing at the bottom, it's still going to give me an error because, oh, whoops. I thought it would have given me an error because const usually can't be reassigned. So let's see. I'm going to try putting const on the max in this case, and I think that should give me an error. Yeah, because we're trying to reassign the value of max here. Whereas when we say const up here, we're saying this value isn't going to change. This is going to be the same the whole way through. So like when I say const max is on the value of statues at 0, I'm saying this maximum constant over here, it's 6. It's always going to be 6. It's not going to be anything other than 6. And if we try to make it something other than 6, we're going to get this error. It's going to say you're trying to assign a value to a constant variable. That's not going to work. Okay, so I'm actually a little curious at why it did work when we put const in here, but that's for another stream, I guess. All right, so I don't think there's much else we could do with this. I mean, if you really wanted to, we could sort of turn the whole thing into an arrow function. Again, it's the sort of thing we would do if we were trying to do a code golfing challenge, and then we just do something like that. So again, name of the thing is assigned a value of this function, which takes this input to this output. That's basically the way it's going to work. We could run the tests. It's still going to pass them, but I probably don't really recommend using that sort of syntax over here. I mean, there's nothing wrong with just saying function. Like we saw, it sort of has its own advantages, its own benefits, like the hoisting we saw earlier. There may be other advantages I'm not really familiar with, but one thing I would say is just the human readability. That's something you sort of want to consider when you're building a coding project. I mean, other people are probably going to be looking at your code. You, in the future, are going to be looking at your code. So make it look nice, make it look understandable. It can be fun to write these code golfing algorithms that are super terse and that get something done, maybe get a complicated algorithm done in very, very few characters, and that's kind of neat. But we got to consider, is it going to make sense to you later? We don't want to have to waste time unpacking this and trying to figure out what we meant at the time. So we do want to consider using semantic kind of notation. We want to make our code as much as possible speak for itself. Okay, so that's it for that one. We're going to take a little break and we'll come back with the 7th task in the arcade. So we'll be back in a few minutes. I'm going to cut the stream for now. So thanks for watching for now. We'll be back real soon.